like ceiling hanging device to put it on.
That would be cool. I actually almost bought a true tripod thing, but that thing's perfect.
Yeah.
Let me see.
One way to make it easier is like if you put that table right over there, it might help.
Oh yeah. What I've noticed is if I make it too direct and I move around too much, you lose some of it. So I almost always have to go sideways, which makes it a little bit. Well, you guys will tell me if it's horrible.
Trial and error.
What'd you get for use those as well?
It comes perfect after all.
What'd you get for DU?
Just 1 over X.
And for D is negative 1 over X, right?
Yeah.
I just made a small error. We got negative 1 over X ln D. Evaluated it.
ln matching.
My husband he's taken second semester recently than I have, but he's natural.
Oh god, it's like opening up my this browser version.
There it is. Like it. Cool. All right. So guys, the idea of a third dimension in itself, you live in 3D, so that's nothing big. But the idea of it mathematically should be nothing new to us, really, by itself. What's the only thing mathematically that changes? If you want to identify a point, obviously you're just going to need an extra component. I love it, right? So far, everything we've done, really, just to make it 3D, I just have to add on there, comma, 0 at the end, which kind of assumes it's all on the XY plane. So up here you can see, normally if I do it on the board, we talk about, here's my XY plane, and then we talk about maybe the Z-axis coming out of the board. Here's kind of the standard way to draw XYZ coordinate axes. It's just like this. So if I was looking straight down on it, that would give me my normal XY plane. Okay. One big thing about the correct way to put these is something called the right-hand rule. Right? And again, this is something familiar to those of you who have done physics, possibly. If you went far enough and did some electromagnetism, the right-hand rule comes in very handy. If you put, I can't remember how the book does it because I do it several different ways. If you put your, along the x-axis, put your hand, and then curl it towards the y-axis, your thumb points in the direction that the z-axis should be. And that's the correct orientation of the coordinate system. If you switch the x and y, obviously it would then point down, and then everything's in the wrong place. It's not good. Right? So we want to keep our coordinate system set up like this. With just 2 dimensions, we have quadrants. With 3 dimensions, we have octants. Yeah, because now I've broken it up into 8 parts. And we also don't just have coordinate axes. We now have coordinate planes, right? So for example, the XY plane is there. The XZ plane is there. The YZ plane is there. So just to give us a little preview, when we start trying to draw 3-dimensional graphs, like graphs of functions that live in 3 dimensions, the first thing we do is we say, what does it look like just in those planes? We call those traces. And then we try to put that together into a big framework. You guys kind of with me on that? I always think about it like we've seen it, PET scan or tomography, when they do that, when they can kind of move through your head or something. When they do a PET scan of your head, they can move through the layers. So I always think about this is like a cross-sectional cut, right? And I want to see just what does it look like there, and then what does it look like here, and what's it look like over there, and maybe all together it makes this parabola thing, or who knows what. Okay, and a little less interesting. What does that do? That does nothing. Oh, I see. That's nothing amazing. Here's the first octant. Not surprisingly, the first octant should be where they're all positive, right?
second octant, third octant, fourth octant. You notice all the first four octants relate directly to the four quadrants, right? You guys with me? So the first quadrant was the XY plane here. The second quadrant was here. Well, the second octant was there. The next four octants are going to be where Z is negative. So it's not that difficult to remember. It's not even really going to come up, but that's how we break it up. Yeah. Sweet. I like it. That's the ignore you for a minute method of teaching. Let's see. Here's a point, and obviously it makes it a lot easier to tell where the point is if you actually trace out how you got there. So the point 2, 3, 4, that's how you get there. Notice how this, of course, must be parallel to this. This, in this case, is easy to be parallel because I'm going along that axis, but do you see how that would be very difficult to do freehand on a piece of paper? Yep. You with me on that? Hell yes, Jeff, we are with you. Okay. So let me show you something real quick. Let's see how quickly I can do this, because if you go to Google, go to images maybe, type in isometric. If you spell it right, it works better. Passport? Yes, isometric passport. That's what I want. Here we go. Dudular. I don't know if you guys can kind of see what might happen. I'm going to bring some next time. We'll do some of this together, but if you set up your...
that looks highly unpleasant.
Let me see if I can do... Oh, I could do this, couldn't I? No. It's bad for me. Screw. All right. The way this would work is you could set up your axes. Here's one. Here's the z-axis, the y-axis, and the x-axis. And then if you move along, and then you can move straight up, and you can move over, it makes it a lot easier to be parallel to those axes. You with me? That's called isometric paper. You definitely want to get some. You're not going to need a ton, but you're going to need some to be able to do this. Yep.
You can just print out those images.
Oh, hell yeah. There you go. Print those out. Do it. On a test, I'll put some of this on there, so you can just go right on there. Right? Coolness. Good. Okay, where do we go? I was done. Okay. Let's see, anything interesting here? So if I move A, need a B. Isometric, yeah. Not isomorphic. Chemistry sometimes comes in and messes up our math. Oh, okay. So I was getting a little ahead of myself. So this section, once you've got 11.1 kind of understood and under your belt, all 11.2 does is add one more component. So I don't have to go over any properties because it's the same properties. How do you add two vectors who are in 3 dimensions? Where you add their components together. Who cares? It's the same thing, right? How do you find the magnitude of a vector? Yeah. So if I have a vector 1, -1, 3, that's u. What's the magnitude of u going to be? Square root of 1 squared plus -1 squared plus 3 squared. Right? Same old thing. You guys with me? Hopefully you've seen that before, because that's sort of like the problem that I think sometimes shows up in earlier courses. How do you go from one diagonal to the other diagonal? Well, you kind of do, you could do this. You can see the distance easier that way. Just go directly and do it. The distance between this point and this point in 3 dimensions. So you have to know that distance formula. Pythagorean theorem just extends beautifully to higher dimensions. 80 dimensions. Same thing, right? What would that be? Let's not get into that. It all depends.
Pascal's triangle.
Huh?
Pascal's triangle quarters.
Pascal's triangle?
Where do you fit?
Would it work here? How do you?
Never mind.
That's right. Oh, think about this. What's the in 2D? What's the line? You know, x = 7. What's it look like? And 1, 2, 3, 4, 5, 6, 7. So like that, right? X equals 7, which means y can be anything, just x must be 7. What does that not touch? The y-axis. There is no y-intercept. It never touches the y-axis. What letter is not present in its equation? Okay, so the plane x equals 7. So if this is 3D, the plane x equals 7. What will it not touch?
The Y or Z.
Be more specific. Not the y or z, but the yz. Beautiful. It will not touch the yz plane because it is, the y and z are not present here, right? If it did touch the yz plane, what is the value of x in the yz plane?
0.
Everybody with me on that, right? Well, what does x have to be? What does x have to be? What does x have to be? 7. So can it ever be 0?
No.
So of course it can't touch the freaking yz plane. But it is nice to realize the shortcut to all that is whatever letter is not in the equation is going to be parallel or at least not touch that thing. So if I had x plus y equals 7, what will it not touch? The z-axis. You guys with me? That kind of is nice. It doesn't help directly with a lot of the stuff when it gets more complicated, but it's kind of nice to realize now. And that's really what that next thing was all about. Here we got the y equals something. And notice how it's parallel. And I'm saying that before you even define it. But I think we all understand when I say parallel to the xz plane, it's another plane that never kind of intersects that. So it's parallel to the xz because y equals 4 does not have x or z in it. Beautiful. So now I love that they put a little scrolly thing and everything. Whee! If we make it y equals 0, that of course is the definition of the xz plane, right? Like x equals 0 is the definition of the y-axis, y equals 0 is the definition of the x-axis, right? So there's a lot of stuff that we know from before that translates perfectly to this. Okay. Oh, so here's a problem that sounds sort of like an algebra problem, mainly because it is just in 3D. Find the equation of the plane. You guys ever seen this before, by the way? It's an abbreviation for equation. So if I write that down, I'm not even going to think about it. That's what I mean, equation. Function, you write down with that. Little n with an underline. So that means equation, right? We know that math people, we're lazy or frugal with our time, whichever way you want to think about it. So we like to find quick ways to write things. Find the equation of the plane going through, doesn't really matter. I'm going to put something down there. 1, -4, 7. That is parallel to the xz plane.
Y equals -4.
So what letters can't show up in the equation of the plane? X and z, because I want to be parallel to the xz plane. Therefore, y must be a constant, right? So y must be what it is right there. It's got to always be that. So y must equal -4. Doesn't that feel like a problem you guys did back in 110 or the equivalent, whatever the hell, a million years ago? Y the greater line is parallel to blah. You know, I've done it before. Okay. Really hopeful. So, I really have not much to say about that. Some of you guys have already started trying the 11.2 stuff out on the back of that quick quiz. Believe it or not, that's all I have to lecture about 11.2. Let's go ahead and try that on the back of the 11.1 quick quiz. There's 11.2 quick quiz. And again, you guys can work together. You guys can call me over if you have trouble.